This is the last lesson you gotta watch. Alright, so last one. This is problem number 3 from lesson 7. Han and Claire, they're running laps around the track. Coach is recording their times. And at the end of 2, 4, 6, and 8 laps, these are the results. Alright? So what it wants us to do real quick is to just do like how many minutes it's taken them to run each lap and fill out the table. So let's do Han real quick here. Han has ran a 2 laps in 4 minutes. So if we want to know how many minutes per lap, we would divide 4 by 2. And that would give us 2 minutes there. And then minutes divided by laps here would be 9 divided by 4. Well, let's use the calculator for that one. That one doesn't come out very nice. So 9 divided by 4. And that gives us 2 1/4. So 2 1/4 minutes on that lap. And then 15 divided by 6. The next one, 15 divided by 6. That comes out to be 2.5, 2.5, and then 23 divided by 8 is the last one there. 23 divided by 8. And that comes out to be 2.875. So it appears as if Han he started off kind of quick, but he's slowing down. It's taking him longer to do each lap as he runs. That makes sense. He might be getting tired, right? He might not be in the best of shape right now. But Claire, as she's running, she has a time of 5 minutes for 2 laps, and 5 divided by 2, if we cut 5 in half, that's 2.5. 10 divided by 4, actually, if we take 10 and we divide it by 4, that is the same as the first ratio, because 10 over 4 is the same as 5 over 2 when reduced. It's also 2.5. So 2.5. She's taking 2.5 minutes for each lap. And then 15 divided by 6 and 20 divided by 8. 15 and 6 and 20 and 8. And they're all the same. They're all the same. They're all 2.5 minutes per lap. So Han's kind of slowing down. Claire kind of set herself on a pace and stuck with it. So Han, is he running at a constant pace? No. Is Claire? Yeah, she's running the same speed the entire time. How do I know? Claire's speed is constant, whereas Han is slowing down. That's how I know. Han is slowing down. And then it says to write an equation for the relationship between distance and time for anyone who is running at a constant pace. Well, we can't write an equation for Han because he's all over the place. We can't just say multiply this by 2 and it always works, right? Times 2 works for the first one, but it does not work for any of the others. Times 2 doesn't work, times 2 doesn't work. But if you have somebody that's constantly running the same speed, hence the constant of proportionality, and let's say that time is, we got minutes here in time, and we got distance. If I want to write an equation for this, and let's say that, y is over here in time, and x is the distance, I could say to get what y equals, I just take whatever the constant is, okay, let's call that constant k, and I'd multiply it by x. Alright, we multiply x by k, we'll get the y. And that's true for any proportional relationship. I can just take the constant of proportionality, multiply it by the column x, and it should give me what y equals. And so this is an equation that works for every situation with a constant pace or constant speed or constant proportionality. It always takes this form.